Okay, before we do plane, remember in vectors 2, we do a line. Okay, so what is the properties of a line? Okay, a line will always consist of a point, like maybe 1, 2, 3, okay, as well as a direction. Okay, just look up here, guys. Okay, 5, 6, 7. Okay, something like that. So how we represent a line is L dot dot R equals to 1, 2, 3 plus lambda direction 5, 6, 7. Okay, so this is how we represent a line, and this is a vector equation of the line. Okay, how to change a vector equation to a Cartesian equation? So remember, R means x, y, z. Okay, in this chapter. So this means that x, y, z is equals to 1 plus 5 lambda, 2 plus 6 lambda, and 3 plus 7 lambda. All you need to do is to make lambda the subject to convert it into a Cartesian equation. So this is x minus 1 over 5. Lambda equals to y minus 2 over 6. Lambda equals to z minus 3 over 7. So the Cartesian equation is like x minus 1 over 5 equals to y minus 2 over 6 equals to z minus 3 over 7. Okay, so conversion of vector form to Cartesian equation form and vice versa. Okay, so next, last week we talked about a plane. A plane consists of, you need a point. So for example, you have 1, 2, 3, and then you will need two directions. Like this is 5, 6, 7, and then this is like 8, 9, 10. Okay, so to define a plane, you need 1 point plus 2 directions. Okay, so the easiest way to represent a plane is R equals to a point, 1, 2, 3, okay, plus 2 direction, lambda 5, 6, 7 plus mu 8, 9, 10. Okay, so you need two directions. How to form a direction? 2 points form a direction. So for example, let's say you have 1, 2, 3 over here, and then you have another point over here that is like 6, 7, 8, right? Yeah, this is how you form one direction. Take 2 points to form one direction. Okay. So a plane will consist of a point, two direction. Okay. Now, so this is called the vector equation form. How to convert it to scalar product form? R. So this is the first one, vector equation form. Second, you have R dot n equals to D. And what is the D? The D is A dot n. What is A? A is any point will do. Okay, so how to convert this? So first, n is called the normal. The normal is a vector that is coming perpendicular out from the plane. Okay, it can come from anywhere. All these are all the same. It will give you the same result. Okay, so how to get a normal from two directions? You need to take 5, 6, 7, cross 8, 9, 10. Because when you cross two vectors, then when you have these two vectors you cross, you are getting a normal that is perpendicular to the plane. Okay, so you cross this, cover the first row, okay, 60 minus 7 times 9, 63. Cover the second row, 50 minus 7 times 8, how much? 56, is it? Yeah, 56. And then cover the third row, downward cross, 45 minus 48. So you will get something like 3 or 6, and then negative 3. Okay, now you know, always simplify. Okay, so a normal is again another direction vector. You can say that this is 3 times of 1, 2, negative 1. So basically always use the simplified form of the normal. So what is the R dot n dot product form of this plane? Is R dot 1, 2 minus 1. So this is the normal. Okay, equals to A. A is a point. You need a point. 1, 2, 3. Dot 1, 2 minus 1. Okay, and then you are going to get R dot 1, 2 minus 1 equals to dot product this 1 plus 4, 5 minus 3, 2. So this. Okay, so remember R dot n equals A dot n. A dot n will give you a scalar. You need to evaluate this A dot n. What is A? Any point on the plane that you have. Okay, and so that's the second form. Okay, and then when it comes to the third form, it comes from R dot n. R dot 1, 2 minus 1 equals to 2. R means x, y, z. So you convert this to x, y, z dot 1, 2 minus 1, okay, equals to 2. So this will become x plus 2y minus z, okay, equals to 2. And this is the Cartesian equation form. Okay, so three different forms. The first one is two direction, okay, so vector equation form. The second one is r dot n equals to d form, and the third one is a Cartesian equation form. Okay, some other things you must note is, so remember, the most important thing of a plane, right, is the direction. Okay, so we're going to use the direction for a lot of things. So for example, this is P1. If P1 is perpendicular to P2, so you see perpendicular, right? Then there's another normal that is going to be coming out here. Okay, so if P1 is perpendicular to P2, it means that their normal is perpendicular. In plane, we always just use the normal. Okay, we always just use the normal. The other things are not so important, actually. Okay, just learn how to use the normal will do. Okay, so now it comes to, there are several relationship between two planes. Okay, so number one, if two planes are parallel, what can you say about normal 1 and normal 2? Jonathan? Yeah, may not be exactly the same. So n1 right now it could be a scalar multiple times of n2, where n1 and n2 are vectors. Okay. Okay. So for example, you have to observe that, can you see this one? P1 is r dot 1, 1, 1 equals to 2. P2 is r dot negative 1, negative 1 equals to negative 3. Also, this means that the P2, right, the normal is actually going downwards. Okay, but it doesn't matter because you see the n1 is equals to k times of n2. Oh, okay, and okay, this one not so important. As long as the d is different, then they are not exactly the same plane already. Okay, as long as the d is different, can already. Okay, so you must see whether n1 is a scalar multiple of n2. Okay, next is if they are not parallel, right, then they will always intersect at a line. Okay, if the two lines are not parallel, the planes will always intersect at a line. Okay, two intersecting plane will never intersect at a point. No. Okay, can. So in order to find the point of intersection, okay, of two planes, always use Cartesian equation. Okay, so first one, P1 and P2 are distinct and non-parallel. Why? So this is r dot. What does this tell you? What does this tell you, Josh? The normal of the first plane, no? Understand? Yeah. What does this tell you? The normal of the second plane, no? Because it's r dot n equals to d. Okay, so first n1 is not equals to k times of n2. Therefore, P1 and P2 not parallel. Okay, so let's convert. P1 is r dot 1, 2 minus 2 equals to 3. How to convert this to a Cartesian equation? R means x, y, z dot 1, 2 minus 2 equals to 3. So I have x plus 2y minus 2z equals to 3. Okay, so this is equation 1. Okay, next you have r dot 3 minus 2, 4 equals to 5. So x, y, z dot 3 minus 2, 4 equals to 5. 3x minus 2y plus 4z equals to 5. And then that is equation 2. Okay, but use your GC. Okay, using GC, go to your Poly simultaneous solver. Two equation, three unknown. Okay, two equation, three unknown. Poly simultaneous solver, simultaneous equation, two equation, three unknown. Okay, next. Okay, I'm going to have x plus 2y minus 2z equals to 3, and 3x minus 2y plus 4z equals to 5. Okay, and then press solve. Okay, so first you need to say that, okay, so so my GC value is like that, x1 equals to 2 minus half x3. Okay, you can write down here for reference first. Don't need to, this is not the correct working, okay, plus 5 over 4 x3. x3 equals to x3. Okay, so how we present is, let z equals to lambda. Okay, so x is equals to 2 minus half lambda. Y is equals to half plus 5 over 4 lambda. Z equals to lambda. Okay, and how you form this into a line? So remember, x, y, z means r. So r equals to 2 half 0 plus lambda negative half 5 over 4 and 1. So this is the point of intersection, is the point of intersection between two papers. So next time, if you're confused, right, just take two paper, right, and put together, see what you get as a point of intersection. Okay, so this is the point of intersection. The answer, the point of intersection is a line. Okay. Huh? Okay, huh? Okay, this one not so important first. Okay, skip, go to the next part. Okay, this is a recap. Okay, angle between two lines, okay, is, so remember, what is the definition of cosine theta? Sorry, A dot B. A dot B is equals to magnitude of A, magnitude of B, cosine theta, right? Yeah. Okay, so if I have two lines, this one is D1, this one is D2. This is actually more of vectors 2. Or cosine theta is equals to d1 dot d2, okay, just write down, use d1 dot d2 over magnitude of d1, magnitude of d2, okay, and then a modulus on the outside, because two lines, right, will always intersect at the acute angle. Okay, yeah. So this is more of a recap for the previous one. L1 is R equals to, so they put this as I, right? So this is 1 plus 2 lambda. This is 1 minus lambda. And this is 1 minus lambda. Okay? So split this into a point plus direction. 1, 1, 1. Okay? Plus lambda 2 minus 1 minus 1. So this guy is D1. Okay? So this guy is the first direction. R equals to, I means X. 3 plus mu minus 1 minus 2 mu and 2 plus 4 mu. Okay? So this guy equals to 3 minus 1, 2 plus mu 1 minus 2, 4. Okay, yeah. So basically, this guy is D2. Okay, these two are still talking about lines, Okay, these two are still talking about lines, All right. So cosine theta equals to D1 dot D2 over magnitude of D1, magnitude of D2 with a modulus on the outside. Okay, so this guy is 2 minus 1 minus 1 dot 1 minus 2, 4 over square root of 2 square plus 1 square plus 1 square and square root of 1 square plus 2 square plus 4 square. Okay, so dot the top, 2 plus 2 minus 4. 0 leh. Right or not? You realize it's 0 leh. So plus what? Square root 4, 5, 6. 16, 21. Anyway, this is 0 lah. Okay, so what is the angle? 90 degrees. You know why? Because look here, can you see d1 dot d2 equals d1 dot d2 equals to 0, right? If d1 dot d2 equals to 0 means L1 perpendicular to L2. So that's why the whole thing is 90 degrees. Okay. Okay. Yeah. Okay, so remember this magic triangle. Okay. Now it's very important to know how to draw a triangle. Okay, a triangle. Okay, so when you see an angle between a line and a plane, right? So the plane, right? Circle the plane and then say that we use the normal. Right down. Okay, circle the plane and then we use the normal. Okay, so this is L and then this is the plane. Okay, now you cannot find the angle between the line and the plane immediately. You must use the normal. So you see, okay, draw this outside here. Draw this. Write down this is D1. Okay, and then draw this and then pointing upwards. This is N, which is the normal of the plane. D1 is the direction of the line. Okay, N is the normal of the plane. Okay, this one, label this as like this. This is called phi. Okay, a circle with this one. Draw a dotted line here, and then label this as theta. Okay, so phi is the angle of line and normal. But what we want is theta, which is the angle of plane and line. Okay, and theta is 90 minus phi. Yeah, theta is 90 minus phi, or rather phi is 90 minus theta. Okay, so based on just now, remember the formula of angle between two lines is d1 dot d2 over magnitude of d1 d2, right? Yeah. But that one is help you find theta or phi. Is to help you find theta only. Circle this. Okay, circle this. This is to help you find phi. Okay, and theta is phi minus 90. So write down cosine phi equals to cosine 90 minus theta, and cosine 90 minus theta is equals to sine theta. So that's why the formula is, in this case, M is D. Clean the M and put D as D. Yeah. So the direction of the line, direction dot normal over magnitude of direction, magnitude of normal. Okay, so angle between a line and a plane, right? We cannot use cosine, we use sine. Okay, why we use sine is because when we use cosine, we are finding the angle between the line and the normal. Okay, we are finding the angle between the line and the normal. Yeah. Because it depends on whether we want acute or obtuse lah. So the question will usually say. Yeah. Correct. Correct.
So in the second diagram, the line is not cute. Is it still the same?
No, actually it doesn't matter because in secondary school, right, cosine 180 degree minus theta is equals to cosine theta, man. You know, so whatever gets here and whatever gets here will be the same. So, okay, basically don't need to worry about these two. Doesn't matter the case one or case two. When you want, doesn't matter the case one or case two. Okay, basically it's just, we just take away the modulus. Okay, sorry, I don't want to make it confusing for you. Okay, so just remember, if you want an angle between a line and a normal, when we get an angle between the line and the normal, we are unable to get theta. We are only able to get phi, which is this guy. Okay, there could be a possibility that phi is this guy, but it's not important at all because we didn't want phi, right? Not. We want who? We want who? Theta. Yeah. So when you want the angle between a line and a plane, is always use sine theta. Okay. Can okay. The example skip first. Okay, next part. The angle between two planes. Okay, the angle between two planes, again, the angle between two planes is the same as angle between two normal. Okay, just write down. Okay, yeah, then it will just be, box it up here, n1 dot n2 over magnitude of n1 magnitude of n2, no modulus. Okay. Can? So find the angle between r dot. Okay, so what is the meaning of this? Isaac, what is the meaning of this? Normal n1, good. What is the meaning of this, Yingxuan? Normal n2. Okay, so basically cosine theta is just equals to 3 minus 1 2 dot 0 1 0 over square root of 3 square plus 1 square plus 2 square. This one you must know that is a unit vector. Okay, 0 1 0 is always a unit vector. The numerator is minus 1 over square root of 14. So theta is obtuse. Okay, because when you cosine inverse negative 1 over square root 14, okay, it's going to give you a angle that is bigger than 180 degrees. Yes, Tracy, tell me the answer. Or rather, Josh, tell me the answer because degree mode. Usually put in degree. Huh? 105.5 degree. Okay? Can? No? Skip this 15.11a first, okay, and go to this part 15 point. Okay, this one is your tutorial question 3 or 4 or 5 or something like that. Okay, find the position of the foot of perpendicular end from Q to the plane, this and hence or otherwise. Okay, find the shortest distance. Okay, so firstly, when you draw the plane, right, it's like a piece of paper. Come draw a piece of paper like that, and then put it as P1. Okay, how do we label this one? Then the next thing is label the normal, and then write the normal equals to. Tracy, what's the normal equals to? Very good, 112. Okay, because there r dot n, so this is always the normal. Okay, so this is how. Now, I want you to know that, right, from the point Q, so label this Q here. 703. Don't 7,0,3. Okay, so don't anyhow label the Q. Q will always lie on the normal because the normal can always move on. This norm is normal. This is also normal. This is also normal. All these normal are the same. Okay, so always make sure your Q is on top of on the normal. Okay, so one, write down. Draw the P1 with normal. 2, label Q on the normal. Oh, okay, understand? 3 is a super important skill. Put the star there. Infer a point on r dot 112 equals to 1. Okay, so remember last week we did this infer a point. So what could be a point that lies on the plane that can make this? Okay, so you see this x, y, z, so you want 1 only, right? The easiest one will be my x is 1 because 1 times 1 is 1, right? Then y and z can be 0 and 0. Okay, so which means that, okay, number 4, label the 100 on P1. Okay, so basically 100 is going to be here. Number 5, draw the hypotenuse to Q. Okay, okay, this is the basics of it. Okay, but not pertaining to finding the foot of the perpendicular, but this is how, can you see we draw the triangle? Okay, number 6, label theta. So where is theta? So remember in vectors 1 is always a hypotenuse and a floor, right? In this case, the floor is not on the plane there. Can you see where is the direction? Where is the direction? Where's the direction? 112, right? Yeah, can you see 112 is the direction? So I got this 1 point at 1 point. I can make a hypotenuse like that, yes or no? Yes, right? So where is the angle? The angle is on the plane or between the plane and the vector and the normal. Which one? Jonathan. Yeah, so the angle theta is here. Understand? But this is how you solve a question like that. Okay, but in this case, the question, okay, this is like the whole elaborated grand scheme of things. Okay, like how you first make a point that is outside of the plane, right? Always label it on the normal. Next one, infer a point that is there. There is also a skill that you need. Okay, then we can draw the hypotenuse, then you can form this triangle already. Okay? It must be between the hypotenuse and the direction. Okay? Yes, write down. Huh? Okay? Can? Now, but actually, in the first place, go to the next page. Draw a plane again. Draw a normal again. 1, 1, 2. This is Q, right? 703. This is N. Okay? So N equals to the foot of the perpendicular. Okay? So that means QN is a line, right? Is QN a line? QN is a line, right? Yeah. A line is, what are the two things that a line needs, Joshua? Okay, so which is R equals to 703 plus lambda 112. Okay, sorry, this is not QN. Clean away. So this is the line of QN. Yeah. Okay, and since ON lies on the line, ON is equals to 7 plus lambda, 0 plus lambda, and 3 plus 2 lambda. Equation 1. This is the part that students always cannot get. Okay? What is the equation of the plane? P1 dot dot R dot 112 equals to 1, right? This is equation 2. Okay? So this means that, so remember, number 1 is equals to R, okay? Because all these are X, Y, Z. Again, this is another thing that students don't understand. Because a point, that's why I keep telling you, R means X, Y, Z, R means X, Y, Z. You want to find the point intersection is always simultaneous equation, but you must know how to sub. Okay? So I sub in the one which is the X, Y, Z. 7 plus lambda. Lambda, so the 0 can only do right. 3 plus 2 lambda dot 112 equals to 1. Okay, so I have 7 plus lambda plus 6 plus 4 lambda equals to 1. Six lambda equals to negative 12. Lambda equals to negative 2. Now you sub into 1. So you found ON equals to 7 minus 2 and 3 plus 2 times of negative 2. 5 minus 2 minus 1. Huh? Understand? So this is how we find ON. Okay? Can? Still got space? If still got space, then you write down QN is equals to 703. QN is like the line. You sub the lambda into the line. Minus 2, 112. Okay? This guy is the lambda. 7 minus 2, 0 minus 2, 3 minus 4. Where? No lah, sorry, my mistake, total mistake. Sorry, total stupid mistake. Yeah. Qn equals to On minus OQ. 5 minus 2 minus 1 OQ, 703. Minus 2 minus 2 minus 4. Okay, so the shortest distance is equals to the square root of 2 square plus 2 square plus 4 square. Okay, because after you found Qn, right, which is here, right? Can you see? Okay, 2 square 4, 4 plus 4, 8. 8 plus 16, 24. Okay, divided by 4, that will be 2 root 6. Okay, yeah. So drawing this triangle, knowing how to draw the triangle, right, to help you find the answer, right, is the hardest. Okay, yeah. So sometimes you need to infer the point, right, to make it into a tree triangle. Or okay, usually we use this method. So if you look at your tutorial, some of you are at question 1, some of you are at question 2, some of you are already at question 3. Okay, so then so question 3, right? Yeah, is totally whatever I taught you. So make sure you know how to draw the triangle. But also, right, many students fail at the first part. In this part, look here, 3x plus y minus 2z equals to 3. Okay, so this is Cartesian equation, right? Yeah, how to form to r dot. So this is the same as r dot. R means x, y, z, ma. 3, 1 minus 2 equals to 3. Then this is the normal, yeah. Understand or not? Okay? This is the normal, yeah. Okay, so for part 1, how to find the perpendicular distance from the origin to the plane. Okay, plane, normal, or origin. Okay, anyway, okay, there is one formula that I want you all to include over here. Let me see whether got space or not. Okay, on top here, 15.11b. Come write down this for me. Okay, r dot n hat equals to displacement of plane to the origin. Okay, r dot n hat, okay, equals to the displacement, okay, or actually why? Because this is basically the, okay, so look here, basically this is the length of projection lah. Okay, so let's say for example this is O. Yeah, and then you have, so this is the normal, can you see? And you need to have another point here. That's where the r comes from. Can you see? So if you can make hypotenuse and direction, the angle is at where? This is the angle here, right? Correct. So be careful in planes and in planes, right? If this is the angle, right, then this one is called what? Perpendicular distance or length of projection. Yeah, because the length of projection is always adjacent to the angle. So this guy is called the big L. Understand or not? Okay, so this guy is called the length of projection. So the length of projection is r dot n hat. Okay, right now. Right now this one can already, it doesn't matter. Okay. So if you look at question 3, or the perpendicular distance from the origin to the plane. Okay, yeah. Okay, so all you need to do is, okay, you need a R, you need a point. So give me a point that is convenient. Tracy, give me a point that is convenient, such that R dot n equals to 3. Yeah, 1, 0, 0. Anybody don't know how to get a 1, 0, 0? Because I want 3, right? X dot 3 can, 1 dot 3 can already, the rest zeros. Okay, so basically the displacement is equals to 1, 0, 0 dot n hat, 3, 1 minus 2 over square root of 3 square plus 1 square plus 2 square. Okay, and then that's the answer. Okay, so this will be 3 over square root 14. That's the answer. That's the displacement. Okay, if you get a negative, what does it mean? Yeah, you can modulus it, yes. Because displacement talks about the direction. No, because it's r dot n hat only. You only one used to use n hat. Okay, can those of you who have even finished 1 and 2 do 1 and 2. Those of you who are 3, 4 continue. Okay, from down here. Isaac, take a look at them.
Yeah, one. So what's the easiest way to do the plane to one?
Again, draw the plane. Draw the point. 1, 3 minus 1, isn't it? Okay. You have a random point here, which is 1, 0, 0. This is the normal. 3, 1 minus 2. The angle is at where? Tell me. Yeah, so this is the angle, right? So you must find out what is this first. The vector A is equals to 1, 3 minus 1. The hypotenuse lah, minus away 1, 0, 0. 0, 3 minus 1. So this is the hypotenuse. Okay, yeah. Okay, so this one, are we looking for perpendicular distance or length of projection? Tell me. Yeah, so big L is equals to A dot D hat. 0, 3 minus 1 modulus it. 3, 1 minus 2. 3 square plus 1 square plus 2 square modulus it. Okay, so that's the answer. Understand? So we are always using length of projection. 3 plus 2 over square root of 14. That's the answer. 5 over square root 14.
Anything if the keys are just
Okay.
Shit. Yeah.
So in this case, right, the plane, right, is like funny one. Is okay, the two plane cannot be on. Okay, so for 3B, right, the two plane cannot be on top of each other. Maybe to make things easier, right? Okay, you can do it on like two separate things. So for example, A is here, right? Which is 4, 3C. Okay, and then I have 2 minus 2, 1. Okay, you need a random point. So this guy is R dot 2 minus 2, 1 equals to 1, right? So I know that the point is like 0, 0, 1 is the best. The point is equals to 0, 0, 1. So this inferring is very important. Then now you can find, yeah. Can see? So first, find the hypotenuse. Four, 3C minus 0, 0, 1. That will give you 4, 3C minus 1. Okay, so the distance is equals to 4, 3C minus 1 dot 2 minus 2, 1 over square root of 2 square plus 1 square plus 2 square plus 2 square plus 1 square. Eight minus 6 plus C minus 1. 4. Okay, this was just going to be 3. Okay, so this is like C plus 1 over 3. Oh, so that's for the first part. Then you draw this thing again. Okay, so try not to draw two of them together. So now you need a point. R dot minus 632 equals to negative 1. Or one point that is easy would be 0 minus 1, 1. Can or not? Minus 3 plus 2, ma. Huh? Say again? 1, 1, 1. Yeah, 1, 1, 1, 1, 1 also can. 1, 1, 1. Okay, if you all insist 1, 1, 1 is fine. Okay, then do the same thing. So the hypotenuse is equals to, so you must know, you must form the vector of the hypotenuse first. 4, 3C minus 1, 1, 1. 3, 2, C minus 1. Okay? So the distance, again, do the same method. 3, 2, C minus 1 dot minus 632 over the magnitude of 6 square plus 3 square plus 2 square. Okay? Minus 18 plus 6 plus 2 C minus 2. This one is modulus. Okay, over 7. Okay, this will make it to become okay, so modulus, right? Yeah, so that's how you get your two possible answer. Possibility 1, C plus 1 over 3 is equals to 2C minus 14 over 7. Possibility number 2, C plus 1 over 3 is equals to, so if it's modulus, that means what? It can be 2C minus 14 over 7, or it could be 14 minus 2C over 7. Because modulus means it could be either be the positive one or the negative one. Because C plus 1 is obviously positive. Yeah. Okay, 14 minus 2C over 7. Very simple. This one, right? Oh. Okay. because both planes are parallel, both of them have the same normal, right? 3, 1, -2. I'm talking about 3 part 3. Okay. And yeah, so this is pi, and then this is, let's say, pi 2. Okay. I know that from part 1, right? The displacement of pi to origin. What's the answer for part 1? Is equals to 3 over root 14. Okay. So for part 2, right, all I need to do is, the same. R dot n hat equal. So this is pi 2 minus 2 1 3 dot 3 1 equals to the displacement. Okay. So 3 1 -2 over square root of 3 square plus 1 square plus 2 square minus 6 plus 1 minus 6. Oh, so this is 1 over square root 14. Okay. So if the distance, the distance of pi 1 is 3 over square root 14. The distance of pi 2 is 1 over square root 14. So the distance of pi 1 to pi 2 is 3 over square root 14 minus 1 over square root 14. And that's the answer, 2 over square root 14. Understand why? Understand why? Because it's like, okay, this is O, right? You are standing 1 over square root 14 away from O. Josh is standing 3 over square root 14 away from O. So what is the distance between you and Josh?
R dot n hat is
Yeah, R dot n hat is for displacement to origin.
One is you can get y equals to subject. And you just find the gradient of the y. And y equals and the other one is so what is good? In fact, y equals subject. Then I have to figure out the y. Y equals to minus p over a. That's a and then the gradient of hyperbola is minus b over a.
Imagine the 1 to be 0. That make y the subject. So yes, in a way, yes, correct.
Okay, so just 1 is 0, and then what is are you there? Minus b over here. The bottom is k. The bottom is k. So is that what is it? That is 1. What is that? You are supposed to do this one. But then the instead of 25, instead of 1 times.
So right now we're going
So
to
there
just use minus b1 change.
You can just use any point, because it will satisfy the small d. R dot,
Right, clockwise. With the minus. The vectors together.
that's different. To get line of projection, we need a vector. Understand? To get length of projection, we need a vector.
Then this one also.
This one is the distance between two planes.
Isn't your finding the last?
Yeah, that actually works. It will give you the same thing as well, actually. So yes, okay. Yes, in a way, another method of doing this one, right, is pi 1 is we have a convenient point, right, which is 1, 1, 1, right? 1, 1 minus 1, right? Yeah, you can also draw this triangle, and then you can, yeah, this one is easier actually. Can you see theta here? Yeah, then this is the length of projection. You find out this is the A dot normal head. Yeah, also can. Okay, when you use R dot n head, right? R means R, this vector, right, is the point to the origin. That's why it's displacement to origin. But if you use this also can, use this also can. Use this is better. Can? So the drawing is actually very fluid. One zero. One thing parallel to the x-axis. Then the line is 1, 0, 0. Can or not? You can use, yeah, this is method 2.
So if I use method like this,
The hypotenuse is like A, yeah, which is -2, 1, 3, or the other way around also can, doesn't matter. 1, 1 minus 1. Okay, so this you are going to get -3, 0, 4. Or then the L is -3, 0, 4 dot 3, 1, -2 over square root of 3 square plus 1 square plus 2 square. Okay, so where?
1 over root of 2.
Oh, -11 Huh? -11 Yeah. Then wait yeah, minus, then this is like -17 over root 14. Which one is the correct answer? It should be 14 over square root. This is the correct one. Because yeah, because if you are negative, right, means you're behind the O. You see? So the O is here, right? You have -11 over square root 14. You have 3 over square root 14. So this total distance is 11 over square root 14 plus 3 over square root 14, which is 14 over square root 14. Rationalize, you get square root 14. Okay? So what went wrong over here? Huh? Yeah, it's not 1, 1, -1 is what? Yeah, 1, cannot like 1, 0, 0. Yeah, correct. 1, 0, 0.
But it is it's not exactly on the plane, but it's also
For four pictures, I find direction of line, which is as a 2.0 function using after.
yeah, so I know I could go on the straight area.
Formula, Then sign inverse. Sign inverse.
If you want to find, I can find the direction. No, right on the Oh, right. Wait, it's different.
Wes, are you okay, Wes? Okay. Look here, guys. 5 part 3, right? Look here. Oh, everybody look here. Put of the perpendicular is what I went through. So C is here. 7 minus 3, 4. Okay. It goes to here. N is here. So this direction is the same as the direction of the normal. What is the norm? What is the direction of the normal? Huh? Say again? 101. One zero. A is 1, huh? Yeah, okay, correct. Yeah, so the question is asking for what is N. So this is a line. The line of Cn is 7 minus 3, 4 plus lambda 101. So this means that ON lies on the line. ON is equals to 7 plus lambda minus 3 as well as 4 plus lambda. Okay? This, guys, is equation 1. Equation 2 is R dot 101 equals to 9. Sub equation 1 into equation 2. Then here. Then you can find the lambda and then sub it back. Understand? Huh? Huh? The line, huh? What do you have for the line? Oh, the direction is wrong lah. You cannot use the direction of the line. Okay? Why you use as the direction of Cn? Cannot, because Cn is there like that. You have to use the normal only. Only can use the normal. And another point will be here. You know, you want N. You find another line no use. You want N. N only lies on this vertical line. Okay. Then, guys, when you see the word reflection, what theorem you use? Isaac? No. Ratio theorem. Oh, okay. So O, C, N, C prime. Okay. Basically, your job here is to find the lambda and then sub it back to here. You get ON already. Then this is 1:1. ON is equals to OC plus OC prime over 2. OC prime is equals to 2ON minus OC.
Division first. Division first. You get AX plus something, then it's not easier to do the station. Might be another one. Usually it happens. You get a simple station. Then you can also see that simple to find ABC, and then this next part then. You can do what we did with ABC. You just says that you're going with ABC. Because they can run with the rest of the operation. Where's somebody like that? Yeah.
Education of the film.
Or which one? X. So x, y, z dot a01 equals to 5a plus 4. Okay, so this means that r dot a01 equals to 5a plus 4. This means that this is the normal, right now.
The first question. Second question. Third question is x equals to y equals to 10. X equals to y equals to 10. Well, there will be two from minimum point equals to 0. So just put the GCM values.
Okay, guys, back up. Now I need to go somewhere. Okay. Yeah. See you next week. If next week I got open for early one, I'll let you all know. Okay. Okay, sir, you can go. Sir, you can go.
Bye.
Bye.